Today we are going to see explanation of splitting up of energy levels of D1 and D2 lines of sodium. This is the most important aspect of Zeeman effect. Zeeman effect was able to prove that splitting up of energy levels is taking place in sodium. So that only it has very great importance. In last classes I have told you what is Zeeman effect. When a spectral line is inserted or when a spectral line is kept in a magnetic field, it is getting split up into two or more. Then that type of effect is known as Zeeman effect. If a spectral line is placed in a strong magnetic field and if it splits into more than two lines or three lines, then it is known as normal Zeeman effect. If a spectral line is placed in a weak magnetic field and the splitting of the spectral line is in terms of three or more lines, then it is known as anomalous Zeeman effect. So we have seen all these three. What is meant by Zeeman effect? What is normal Zeeman effect? What is anomalous Zeeman effect? Now the most important aspect of Zeeman effect is splitting up of energy levels of sodium lines. In sodium there are two lines. They are known as sodium D lines, D1 line and D2 line. The wavelength of sodium line D1 is 5890 Armstrong and the wavelength of the second line is 5896 Armstrong. But in general, when we are using the wavelength of sodium light, we are writing it as 5893 Armstrong. So how is that splitting taking place? I told you have to remember two important processes. One is absorption of energy, another one is emission of energy. When an atom or ion moves from ground state to excited state, it will take energy along with it. So absorption of energy takes place. When an atom or ion jumps from higher energy level to lower energy level, that is from excited level to ground state, it will give out energy and that is known as emission. Likewise, now we are going to see the splitting up of spectral line in sodium due to the application of a strong magnetic field. When a strong magnetic field is applied on sodium light, the J vector, that you have to remember, the J vector in it precises. Due to precision, splitting up of energy level takes place, and that energy level splitting is nothing but change in energy, and that change in energy is expressed as delta E is equal to EH by 4 pi m Bgm of J. Delta E means change in energy. Delta E means change in energy. The change in energy delta E is equal to EH by 4 pi m. H is Planck's constant, E is charge of the electron, m is mass of the electron. You know charge of the electron 1.6 10 power minus 19 coulomb. Mass of the electron is 9.1 10 power minus 31 kg. B, strength of the applied magnetic field. G is Lagrange splitting factor or G factor. M of J is the vector. So when you are applying this, the J vector precises. Therefore, when precision takes place, the atom will move from ground state to excited state or excited state to ground state, and there will be splitting up of energy. That splitting up of energy, I got one constant factor EH by 4 pi m is called the Lorentz unit, because this was found out by Debye and Lorentz. The unit is named after them as Lorentz unit. So this diagram shows the energy level splitting of D1 and D2 lines. When I told you about quantum numbers, I told you there are various quantum numbers, and I told you ML is the orbital, magnetic orbital quantum number. The splitting up of energy levels is due to the orbital magnetic quantum number. So this is the splitting of case in D1 line. This is the splitting experience in D2 line. So there are two different lines, D1 line and D2 line. And then ML plus half minus half plus half. So 2p one state. There are S state, P state, D state, F state. So when electron is revolving in an orbit, the innermost level is the S level, this is the P level, D level. So it's going on S, P, D, F. Now when an electron is jumping from 2p1 to 2s half, there are two spectral lines. This is due to D1. So when a spectral line, when a magnetic field is applied on a spectral line, it splits into two lines. Again, when you are applying magnetic field, it is further getting, the sodium line is further getting split up into D1 and D2 line. The D1 and D2 lines are known as fine structure of sodium alkali atom. The two lines D1 and D2 are known as fine structure lines of sodium alkali atom. This is the most important property of sodium. Likewise, when I told that when a magnetic field is applied in a hydrogen atom, the hydrogen atom will be split up into four spectral lines: H alpha, H beta, H gamma, H delta. Likewise, when a magnetic field is applied in a sodium line, it will be split up into two, and that is known as fine structure of sodium alkali atom. So this is nothing but jumping of electrons. That is nothing but, so this jumping of electrons is based on the selection rule. It is based on the selection rule. Selection rule delta M of J is equal to 0 or plus or minus 1. So I have done plus or minus 1. When no magnetic field is applied, there will be no splitting. Therefore, the selection rule applies to 0. When you are applying magnetic field, it will be split up into plus or minus 1. That means in the last classes I told you, spin is of two types: positive spin, negative spin, clockwise direction, anti-clockwise direction. It is plus half means clockwise direction, minus half means anti-clockwise. So you can see that an electron is jumping from minus half to plus half to minus half to plus 1, minus half. So therefore you will get the selection rule value as plus 1 by 3, minus 1 by 3. So this is for sodium line. Further, when you apply magnetic field, you can see that now the electron is jumping from 2p3 level to 2s1 level. Here it is jumping from 2p1 by 2 level to 2s1 by 2 level, D1 line. When the electron is jumping from 2p3 by 2 to 2s1 by 2, we are getting D2 line. So it is having 6 sub levels. These levels are known as 6 sub levels. That means the electrons are jumping. When the electrons are jumping, splitting up of spectral lines is taking place, and due to the splitting up of spectral lines, we are getting a spectrum, and that spectrum is known as sodium spectrum. How is it happening? You have got two wavelengths. You know that there is a relation between frequency and wavelength. If the wavelength is larger, frequency will be smaller. If the wavelength is smaller, frequency will be larger. That you have to remember. Nu is equal, E is equal to E is equal to H nu. Where nu, you know, E is equal to H nu. Energy is expressed as E is equal to H nu, or you can write this H into C by lambda. So the longer wavelength is due to the jumping of electron from 2p1 by 2 to 2s1 by 2, D1 line, and the shorter wavelength is due to 2p3 to 2s1, where we get D2 line. So this is known as the fine structure of sodium D lines. This question they will sometimes ask in 5 marks, or sometimes they will ask in 10 marks. According to that, you have to write. Already I have sent the notes regarding the this question. So you prepare according to the question. If they ask in 5 marks, draw a diagram, mention important points enough. If they are asking in section C, how to draw the diagram, explain about the energy level, then you have to write about the difference in energy, then Lorentz unit, selection rule, longer wavelength, shorter wavelength. All this put together, we are coming to a conclusion that here the Zeeman effect is very much satisfied. The last conclusion is the splitting is occurring due to Zeeman effect. Thank you.